Hello, my Algebra 2 students. Today is day 10, and we are talking about the quadratic formula. You might have learned like a little song to this before. And so if you know it, awesome, because that helps remember, but it's on the Regents reference sheet. So you don't have to know that. All right, before we write it down, let's chat about like what is the quadratic formula even used for? So where it comes in is to solve a quadratic equation. So this is when you have, something like, let's say ax squared plus bx plus c equals 0. Your options. First option, always try to factor first. That is the fastest, easiest way, I think. So if it's possible, try to factor it. It doesn't always work, though. So your second option that we've talked about is completing the square, which is kind of cool, but can sometimes be a little complicated. And then your third option is to use the quadratic formula. Right? These two, they always work. So they are good to know. All right. So for the quadratic formula, what you have to know is for a quadratic equation in this form, right? So where it's ax squared plus bx plus c equals 0, where a, b, and c are just constants. And they can't be equal to 0. If they're, well, I shouldn't say that. A can't be equal to 0, because if a is 0, it's not a quadratic. All right. To solve, you know that x will always be equal to negative b plus or minus the square root of b squared minus 4ac, everything divided by 2a. Right? And this is on the Regents reference sheet. So even though I said you might know a little song to do it, you do not have to memorize it, right? Some know it by the tune of like Pop Goes the Weasel. I forget what the other one is, but we can chat about that in class. All right, let's just talk about how to use this. So for an example, we'll do example 1 here. I'm going to give you x squared minus 3x plus 2 equals 0. Mm-hmm. So to do this using the quadratic formula, I would always say state what a, b, and c are off to the side. So if there's no number in front of the x squared, we know that's just a 1 right there. B would be negative 3. C is that positive 2, right? And so that means that x, the solutions for x, which should be equal to negative b, so that's going to be positive 3, plus or minus b squared, so negative 3 squared, minus 4 times a times c, and then everything divided by 2 times a. Right? This is what should always work. And then start cleaning it up. You could type this entire thing into your calculator if you needed to. Otherwise, we can say that this is 3 plus or minus underneath the radical. Negative 3 squared is 9. 4 times 1 times 2, that's going to be 8. And then all over just 2. So we would end up with 3 plus or minus as a single value underneath there. It just comes out to be square root of 1. All right, and then once you can actually take the square root, you end up with 3 plus or minus just plain old 1 equals 2. So this is going to give us 2 separate values. So x is really going to be equal to 3 minus 1 over 2, and x will also be equal to 3 plus 1 over 2. And then you can calculate each of those values separately. So 3 minus 1 would give me 2 over 2, or the first solution would be 1. If I do plus, that would give me 4 over 2. Second solution would come out as 2. Right? So when you get these nice, pretty answers, right? And when I say pretty, I mean that they are real numbers. And they're also rational. So they're nice whole numbers, or nice fractions are rational values, right? That means it could have been factorable. So if I actually go back up to the original and say, all right, well, x squared minus 3x plus 2 equals 0, you might have been thinking this as I was working through the quadratic formula anyways, that we could have just said, hey, what adds to negative 3 multiplies to 2? That would be a minus 2 and a minus 1. And then there's those 2 solutions. So that's what I mean by if it's factorable, That's always going to be the fastest way. But if you don't see how to factor it, quadratic formula works regardless. It just takes a little bit more work to get there. So that's the nice thing, is it's a guaranteed way to be able to solve. All right, example 2. I'm going to give you 4 minus 2x and then equals x squared, right, with the directions to solve for x. So when you think about, what do I have to do for this? First things first, you got to get it equal to 0 so that we can see what's going on here. So if we move everything to the other side, I always like to keep x squared positive. We're going to add 2x over, subtract 4. In this format, now you can look at it to see, like, can I factor it? So in terms of that, you know what adds to 2 multiplies to 4? Nothing. So I would still, even though we're practicing quadratic formula, still get yourself in that habit to see, like, could I factor it? Because you can't factor. Completing the square or quadratic formula would now be your options. You can do completing the square, but this is what we're focused on. So I want you to state over here, what's your A, B, and C? And let's go with the quadratic formula here. So this is 1, 2, negative 4. All right, x equals, you can have your Regents reference sheet next to you, you can have your notes next to you, or you can start singing the song to yourself. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, if you need to, can you use your calculator to help you? Of course you can. What I would suggest if you're going to use your calculator to help you would be to calculate the part underneath the radical without the radical attached. So what I mean by that is if you go to your calculator, you could do, you know, the 2 squared and then minus 4 times 1 times negative 4 to get that piece of it. That is where I see the most mistakes, because people don't realize the negative times negative, that part turns to positive. Otherwise, if you did that piece on your own, you would end up with 2 squared, so 4, and then plus 4 times 1 times 4, so plus 16. That's where you'd get that same radical 20. So either way, that's your choice, right? So we should have negative 2 plus or minus radical 20, and then all over 2. So not as pretty as last time, but we knew that because we knew we couldn't factor it. Once you get to here, you now need to simplify the radical. So radical 20, I got it right above here. That'll be radical 4 times radical 5, or 2 radical 5. So let's substitute that in. So this is x equals negative 2 plus or minus 2 radical 5, all divided by 2. Now make sure the numerator is a binomial. Each part of the binomial is getting divided by 2. So if you need to show it and say that part divided by 2 plus or minus this part divided by 2, all right? So negative 2 over 2, that would give me negative 1. Here the 2's cancel as well, and you're left with plus or minus radical 5, just like that. So there's your 2 solutions. When the solutions are written like this, it's perfectly fine to keep them together. Your other option would be to say, okay, well, I can write it as negative 1 minus radical 5, and then negative 1 plus radical 5. That would be fine as well, or it's fine to stop here. All right, looking at those solutions, when you're stuck with a radical, that's fine. If I type it into the calculator to give me an idea of what that number is, like negative 1 minus radical 5. Whoops, not what I meant to type. Negative 1 minus radical 5. There we go. It's like negative 3.23 dot, dot, dot. And then if I do negative 1 plus radical 5, that's about, 1.236, and it keeps going, all right? I'm not super worried about that. What I want you to recognize is that when I'm left with that radical there, these are still real numbers. They're just kind of messy, which means they're irrational. When you have a radical that you can't simplify, these are real irrational answers. All right, let's do one more. So example 3. You're going to start with x squared plus 24x, or excuse me, plus 24, and then equals 6x. All right, just like last time, let's move it over so that everything is equal to 0. So we would get x squared minus 6x plus 24 equals 0. Convince yourself that you can or can't factor it. So multiplies to 24 and adds up to 6. Well, nothing's really going to work there, right? So we can go right to saying, all right, well, let's use then the quadratic formula to try this one out. All right. And now something to keep in mind, all the examples we've done so far, the a value's been 1. That will not always be the case. So when we see each other next in class, we'll look at an example where what happens when that changes? What does that look like in the problem? Otherwise, we can go right into negative b plus or minus square root of b squared minus 4 times a times c, and then all over 2 times a. All right. We've got 6 plus or minus. Okay, let's take a look. This would give us 36. 4 times 1 times 24. That's going to give us 96. And it's minus that 96 all over 2. 36 minus 96. We're going to be left with negative 60 underneath the radical. All right. We've talked about what happens when you get a negative underneath there. That's going to be imaginary right there, all right? So when you go to simplify that radical, and maybe you do the work off to the side here, biggest perfect square, it's not that big of a number. It's just a 4. So 4, 15 is my leftover, but then I also have to separate out that square root of negative 1. And so when we do that, that turns into 2, radical 15, and I. Make sure that I is not underneath the radical when you go to write this down. Otherwise, you might confuse yourself. So we've got 6 plus or minus 2 radical 15 I, all divided by 2. Now, it won't always simplify out, but this one does. So you can show it as separating it, or you can show it as take each piece and divide by 2. It doesn't really matter to me. I can show it both ways. It might be easier and less busy looking if you actually split it up. So this produces then a value of 3. Plus or minus. Here, the 2's cancel out, so you're just left with a 1 there. So really, it's 1 radical 15i, but it's perfectly fine to just write it as radical 15i like that. All right, and how we would classify this. These are then imaginary answers. All right, which doesn't mean that it's an imaginary equation. It just means that the actual solutions are imaginary. All right. Thanks so much for watching, guys. Go answer the post video question right now, and I will see you in class soon.